Our lab is interested in rapid prototyping and testing of autonomous vehicles, which are vehicles that can complete a certain set of tasks without human intervention. So as researchers, we're very interested in seeing how our algorithms work in the real world, where sensory measurements are often imperfect or even distorted. In these scenarios, vehicles often make an estimate or a belief of their best perception of what the environmental model looks like and then makes a decision based on that. But this magnifies when you have a very complex system of agents interacting together, and it's very hard to understand why the algorithm behaves in a certain way. What we'd really like to be able to do is to be able to read the minds of our autonomous agents and get some idea of how their decision-making processes work. Additionally, we'd like to be able to test our algorithms on a variety of environments so that we can robustify them.
So this new system, which we refer to it as measurable virtual reality, it basically combines a projection system and a motion capture system. We use the projection system to project a simulated environment, and we call it the system a measurable virtual reality because we measure this projected scene using actual sensors that are mounted on autonomous robots, say ground robots or aerial robots basically. And we, at the same time, we have this motion capture system which tells us where this physical system, the robot we're working with, located in the 3D environment. And combining this motion capture, the information we are getting from motion capture system and the projection system, we basically enabled fast prototyping of cyber-physical systems, or in other words, the faster design of these learning, perception, and planning algorithms for autonomous systems.
So this work can be applied in multi-agent scenarios where a single agent can have control over the actions of other agents in its team. For example, you can think of a scenario where an agent can communicate with nearby agents, but only within a certain radius of communication. And as this leader agent moves around in its environment, it can link up to other agents and give them tasks to do in real time. This was work that was previously very hard to convey to spectators from outside our lab because it was difficult to ascertain when that communication link occurred. But now, using our system, we can in real time see when that link up occurs.
One of the limitations these days in designing the autonomous systems are the regulations out there in society, right? We cannot easily run autonomous cars or the flying robots outdoors due to the regulations. So the system allows us to bring outdoors in basically and simulate this outdoor world and then using the actual sensors actually measure this projected scene as if the robot is flying or driving outside in the real world environment.
So our system allows us to transform any indoor lab environment into a complete virtual reality simulation, which is perceivable by any type of autonomous agents. So we're hoping that this system can become a future indoor environment in which private institutions can test and research their vehicles before deploying them into the real world.